Hi everyone. This video we're going to take a look at three types of inequalities: linear, compound, and absolute value from section 1.7. Before we jump right into solving inequalities, let's first go over the basics of set builder and interval notation, what the difference between those two types of notations are, and how we can transfer that on a number line. So set builder notation is in the first column, the left-hand column right here. And the notation is what you're used to. So for the example one, we have x is greater than or equal to -2 and less than 5. So we read it from the point of where x is positioned. And how we write it in an interval notation is what this means is all the values that we're calling x are between -2 and 5. So we're going to write -2 and 5. It looks like a coordinate or a point, but it's an interval. So don't get confused between this as a point and an interval. And then because it's less than or equal to, we're going to do bracket. For 5, it's just strictly less than, so we use parentheses. So for this interval, how we read this as is bracket -2 to 5, parentheses. On the number line, we're going to go to -2 and do a bracket there. On 5, do a parentheses, and all the numbers in between -2 and 5 are going to be shaded. In some cases, sometimes in other different books, you may see that a bracket gets closed circle and then an open circle for parentheses and then shading in between. Okay, for number 2, set builder notation is x is less or greater than 1, but less than or equal to 6. So interval is we're gonna go from 1 to 6, but because this is less than, we do parentheses. This is greater than or equal to, so we do bracket. And same thing here at 1, get open parentheses, 6 gets a bracket, and then everything in between from 1 to 6 are included in our interval. Okay, let's take a look at example 3, x is less than 1. This is a little tricky because you only have one bound, right? And so what this means is any number less than 1 is included in the interval. And how we write this is -infinity to 1, parentheses, because it's strictly less than. And so at 1, we're going to do open parentheses. This is this side along the negative values is -infinity. This side on the right-hand side is in positive infinity. So we're going to shade everything and then do an arrow because we are trying to go all the way, covering all the values towards the negatives. Now, in the next example, 4x is greater than or equal to -2 means that all values greater than 2 to infinity are in our interval. Now, the 2 is going to get bracket because of this equal sign. Infinity symbols always get parentheses. And now we're going to do 2 bracket all the way to positive infinity. To summarize, whenever you have less than or equal to or greater than or equal, you're going to use brackets or this way. If you just have strictly less than or greater than, you might use parentheses. And infinity symbols always get parentheses, like if you have -infinity to some value or some value to infinity. And notice how the -infinity always goes on the left-hand side and positive infinity always goes on the right-hand side. Okay, let's take a look at solving linear inequalities next. Now for this example, we have 7 minus x over 4 or divided by 4 greater than 8. We're going to solve for x and then use interval notation to express the solution and graph on the number line. So with 7 minus x over 4 greater than 8, let's take away the 7 first. So subtract the 7 first from both sides of the inequality. The 7 is going to cancel out. So we subtract 7. And then we have negative x over 4 is greater than 8 minus 7, which is 1. Okay, because we have, oops, that should be a 4. I tend to do that. 4. Okay, let's get rid of that 4 by multiplying both sides by 4. That will help us cancel that 4 in the denominator. And then we have negative x is greater than 1 times 4, which is just 4. Now here, because we still have this negative symbol, we can get rid of that by dividing both sides by negative 1. So we're going to divide by negative 1. And the negative cancels out, and we have x's. Whenever we are dividing both sides by a negative, your inequality is going to flip over to the other direction. So because it was greater than, we're going to flip it over to less than. Then 4 divided by negative 1 is negative 4. So I'm going to write a note here. Flip the inequality when dividing both sides by a negative. Negative. Okay, so this is the solution. It's a set builder notation. Now we're going to transfer this on a number line. It says x, all values of x is less than negative 4. So I'm going to go to negative 4 to the number line. Because it's less than, we're going to use parentheses. And we're going to go open the parentheses this way at negative 4 and shade everything to the left. I have some students saying how they remember which side to shade when it's, x is less than something is they look at where the inequality is pointing. Because this inequality is pointing like the left direction, they know to shade everything along the negatives. Okay, so we know this is going from negative infinity to 4. So there's our interval. It's easy to do number line first, I find, and then write the interval using your number line. Okay, there is our first example. And now let's look at number 6. 6 says x minus 2 over 8 greater than or equal to x minus 1 over 12 plus 1 over 24. Okay, when we're dealing with fractions, right, we always want common denominators. And the common denominator of 8, 12, and 24 is 24 because they all divide into 24. So my goal is to get all the denominators to be 24. And in order to do that, we have to multiply by the multiplier that will give us 24 in the denominator. Let me just rewrite this again, x minus 2 over 8, and put in parentheses. So first fraction, we're going to multiply this by 3. Greater than or equal to the second fraction, x minus 1 over 12. We're going to multiply by 2. And then the last 1 over 24. We don't really need to do anything with that because it's already 24 in the denominator. So what we have here is 3. Parentheses x minus 2, and we have 24 in the denominator, greater than or equal to 2, parentheses x minus 1 over 24 plus 1 over 24. Now we can cancel out all the denominators because they're all common, and then what we are left with is a numerator. So now what we have is, actually let's multiply here, the 3 and the x minus 2, we're going to multiply 3x minus 6 greater than or equal to, multiply the 2 in, distribute the 2x minus 2, and then we have plus 1. And now let's simplify like terms on the left hand side. I think there it's already actually pretty simple. Simplify on the left. 2x minus 2 plus 1. Let's combine these guys. Negative 2 plus 1 is negative 1. So we have 2x minus 1. With inequalities, always try to get the x terms all collected on the left. So we can subtract the 2x over, and we subtract the 2x away. 3x minus 2x is x. Minus 6 is greater than or equal to negative 1. And now lastly, we're going to add 6 to both sides. And that cancels away. So we have x is greater than or equal to negative 1 plus 6, which is positive 5. So here's set builder notation. And now let's put that on the number line. So because it's greater than or equal to, we're going to go to 5 and then do bracket. And because x is everything that's bigger than 5, we shade the numbers to the right, going towards positive infinity. So our interval is bracket 5 to infinity, parentheses. Okay, number 7 is 4 parentheses x minus 3 minus 6 parentheses x plus 1 greater than or equal to negative 2x minus 7. You don't have to deal with fractions here, but there's parentheses. So let's distribute the 4, distribute the negative 6, and simplify the left-hand side so we don't have to deal with the parentheses. We have 4x minus 12 minus 6x minus 6 greater than or equal to negative 2x minus 7. And now let's combine like terms. The 4x minus 6x gives us negative 2x. Negative 12 minus 6 is negative 18. Still greater than or equal to negative 2x minus 7. We try to collect the x terms on the left. So we're going to add this 2x so we can cancel that. And it happens that it also cancels this x term as well. So we have negative 18 is greater than or equal to negative 7. You don't see right away here, you could try adding this 18 over and let's see what we have. So the negative 18 cancels and we're left with 0 is greater than negative 7 plus 18, which is 11. Now think about what that means. 0 greater than or 11. Doesn't make sense, right? How can 0 be bigger than 11? So since this inequality is not true, or never true, we conclude that this inequality has no solution because 0 is not greater than 11 ever. So on the number line, there's nothing to shade because there's no solution. And an interval, there's also nothing. There's no solution as well. So we write a 0 with this slash, which means this is no solution. It's an empty set. So sometimes your inequalities might be empty. What does that mean? It means this inequality, I can't find any number that will make this, the left-hand side greater than or equal to the right-hand side. Okay, let's take a look at compound inequalities. Compound inequalities, the idea is that you want to isolate the x variable in the middle. And you'll see why we call these compound inequalities. We call it compound because there's 2 inequalities, right? And you see x in the middle of that. And so you're dealing with the left-hand side, the middle part, and the right-hand side. The goal is try to isolate the x in the middle. So whatever x has in the middle here, here we have a plus 5 or 1/4. We're trying to get rid of those. So x is isolated all in the middle. Here, the plus 5, let's get rid of that first. So what we need to do is subtract the 5 in the middle. There's 3 parts, right? And so we have to subtract the 5 on the left, 5 in the middle, of course, and 5 on the right. And that's why it's called compound. And now the 5 in the middle gets canceled out. 3 minus 5 is negative 2. That's less than or equal to 1/4 x less than 1. Now this 1/4, we can get rid of the 1/4 by multiplying both sides by 4 or all 3 sides by 4. And then we have 4 times negative 2, which is negative 8, less than or equal to x less than 4. Let me show that the 4 is canceled. So we have x in the middle. It means it's between negative 8 and 4. We can also read this as x is less or greater than or equal to negative 8, but less than 4. Okay, so it says express your solution in interval notation. I'm not asking you to do a number line, but if it helps, we can also do a number line, a brief number line here. We have 0, negative 8 somewhere on the left, 4 here. And at negative 8, we're going to do bracket. And at 4, we're going to do parentheses. And every number in between gets shaded in. So in terms of the interval, we can see on the number line, it's bracket negative 8. Oops. It's almost, that look like infinity symbol, -8, 4, and then parentheses. If you can go straight from set builder notation to interval notation, that's fine, but sometimes it's really helpful if you put it on a number line first. Okay, now moving on to absolute value inequalities. Last time we looked at absolute value equations. Now we're going to see what absolute value inequalities look like. This is a little tricky because not only are we dealing with absolute value bars, but we're also dealing with inequalities. So what does this even mean when absolute value bar is less than 3? Last time when we had said absolute value bar is equal to 3, these were all values that were 3 units away from 0, which were 3 and -3. So there were 2 solutions. In this case, we have less than. What this means is all numbers that are within 3 units away from 0, not including 3. So if you think about that, right? 1 is within 3 units away from 0. 0 is the center. 2 is also 1.5. We could also have 2.5. Not 3 because it's strictly less than, so we don't want to include 3, but any number up to 3, like 2.9, are values less than or within 3 units away from 0. 0.5 can be 0.1. If you go on the left-hand side, we could have -1, -2, or -2.9. So if we shade all these numbers in, you can see all of these numbers are within 3 units away from 0, but not including -3. So we're going to put a parentheses around the -3 and 3. So if we rewrite the inequality without the absolute value bars, how we write this is x is greater than -3, but also less than 3. So this translates, if we take the absolute value bars off, translates to x is greater than -3 and less than -3. So interval notation, maybe parentheses. I almost wrote a bracket and I caught myself doing that because there's no equal symbol. We do parentheses -3 and 3. So I think the tricky part is making sure you know how to go from absolute value bar less than 3 to writing it without the absolute value bars. It becomes a compound inequality. Okay, let's take a look at, so here's the case, the first case when it's less than 3. So we're going to solve this here, solving this absolute value inequality. Absolute value bar of 2 parentheses x minus 1 plus 12 less than or equal to 6. So we have to first write it without the absolute value bars because it's less than or equal to 6. We're going to rewrite this so that the term or the expression inside the absolute value bar comes out of the absolute value to x minus 1 plus 12. Actually, I might need more space. Let me just write it above. And then we're going to write less than or equal to 6. But then also this has to be greater than or equal to -6. And again, if you're not sure how we did that, we're using this reasoning. If it's inside the absolute value bar, less than 6, the x comes out and it's squeezed in between the -3 and the 3. Same idea. The terms inside the absolute value comes out and it's squeezed in between -6 and 6. And now we would solve it like a compound inequality. And now we're going to do that by, there's a couple ways we can do that here. We could, let's distribute the 2 first. So -6, 2x minus 2 plus 12, less than 6. Combine like terms, and -2 plus 12. So -6 less than or equal to 2x plus 10, less than or equal to 6. Our goal is to get x isolated in the middle. So we can subtract the 10 on all 3, the left and the middle and the right side. And I'll carry it over here since I'm running out of space. So on the left-hand side, we have -16. Let's see. negative 16, and then less than or equal to 2x, less than or equal to negative 4. And finally, we can divide the 2 away. And so x is isolated in the middle. On the left-hand side, we have negative 16 divided by 2, which gives us negative 8. And then x is less than or equal to negative 4 divided by 2, which is negative 2. So here's set builder notation. Now we're going to write that in a number line. And this means x is between negative 2 and negative 8. So we'll write bracket, negative 8, negative 2, and another bracket. I'm not asking you to do a number line here, but if it helps for you to do a number line, you can certainly do so. So we have 0 here, negative 8, and negative 2. You could do bracket and bracket around the negative 8, negative 2, and everything else is shaded in between. Okay, let's look at the second case. What happens if its absolute value bar greater than or greater than or equal to 3? So the direction has changed. This is now greater than. What this means is, and I don't have a number line here. Let's see if I can copy and paste this. I meant to do that earlier. Okay, there we go. So x is greater than or equal to 3. So if you think about all your friends who live further than 3 miles out from you. So before, in case 1, if you think about this, these are like all friends. So if you're 0 and you're trying to find all the friends who live within 3 miles from you. But this one is you're trying to find friends who are, if you're 0, so you're 0, we're just going to pretend you live where 0 is at. If you're at 0, find all the friends who are 3 miles or more, greater than. Their distance is 3 miles or more from where you're located. So that's definitely going to be 3. It's going to be 4, 5, 6, 7, and so forth. And of course, all these numbers in between. And then on the negative direction too, these friends are also, and I keep saying friends, but you know what I mean, numbers, friends. These number friends are more than 3 units away, 3 miles away. We include 3 this time because of this less equal symbol. So if we think about it, this is going to be negative 3 and every number below that, and 3 and every number above that. We don't include 1, 2, negative 1, negative 2 because they live too close. We want numbers that are 3 units or more away. So how we write this in absolute value bars, this is going to be a tricky part. You see how there's 2 parts now, 2 number lines, although it's 1 solution. I shouldn't say 2 number lines. There's 2 parts to this number line. And so you're going to have 2 parts in your notation. And how you write this is you write it as negative infinity. So it goes from negative infinity to negative 3, bracket. And we write union, saying this is also and 3 to infinity. So you see how it has 2 parts. This is all 1 solution. Again, it's 3 parts because there's 2 parts on the number line. Actually, that should go on the number, this builder notation. 1 second. How we write that as without absolute value bars, I went ahead of myself, is x is less than or equal to negative 3, or x is greater than or equal to 3. Okay, so whenever you have x, absolute value of x is greater than or equal to 3, it transfers to x is less than or equal to negative 3, or x is greater than or equal to 3 without absolute value bars. And the interval notation is written as following. So let's practice one. Solving this absolute value inequality. 10 is absolute value of 2x minus 4 is greater than 8. So we first need to write it without the absolute value bar. So this, because it's greater than, we know it's going to be separated into 2 separate equations, or, so we're going to write 2x minus 4 is less than negative 8, or 2x minus 4 is greater than 8. So you're dealing with 2 separate equations, and now you're going to solve 2 separate equations, or 2 separate inequalities. So we're going to add 4 here to cancel this 4. Let's do it on this side too. Cancel this 4. And then on the first inequality, we have 2x is less than negative 8 plus 4 is negative 4. Then we have 2x is greater than 12. Let's divide this 2. Let's also do it here. And we have x is less than negative 2, or x is greater than 6. So you're dealing with two separate, it looks like two separate solutions, but it's all one solution. Two separate inequalities for one solution. So we're going to transfer this into an interval notation. This is right now what we have is set builder. And again, if it helps you, do it on the number line first. So you have 0. We have negative 2 on this side, and you have 6. X is less than negative 2 means we're going to do parentheses and shade everything to the left. We have 6, we're going to shade everything to the right. We have negative infinity, positive infinity. So set builder notation, or interval notation rather, is negative infinity, negative 2. And then union, skip over to 6 and infinity. 9 and 10 might be tricky because you have to get used to breaking the absolute value bars and rewriting it into linear inequalities. Okay, similar to last time, I do have a couple of, calling them in-class assignment problems, although we're not in class together. We're in an online class together. So here's an online in-class assignment. There are 4 separate problems. Again, choose one. Ideally, I would like you to practice all 4, but for submission, try one of these problems and just attach it at the end of your note somewhere on extra sheet of paper, because I don't think I have enough space for you to do it on my guided notes. So add an extra page, choose one problem that you would like to get feedback on. Okay, this is not graded for like correction or right or wrong. It's really to see if you really tried to work it out. And so choose one problem that you think is the most difficult for you, and I will provide feedback. All right. So I hope this was helpful in helping you understand more about the 3 inequality types. And I will see you back in our next video.